Greeting mathematicians. Today we're going to go over the Pythagorean Theorem, but first, what you've been waiting for. All right, let me get set up here. Let's see, there we are. All right, so we learned last block with our lab that the Pythagorean theorem is a squared plus b squared equals c squared. And just a reminder, it only works for right triangles. We definitely need to have that 90-degree angle. And we know it's a 90-degree angle. In geometry, the little box in the corner indicates that this angle is 90 degrees. Now remember, the two legs make up that 90-degree angle. The opposite side is the hypotenuse. And I'm going to label this leg A and this one B. And remember, the legs are, we can label them either way. This could be B, this could be A, B. But definitely the hypotenuse is that longest side of your right triangle, and we are going to label that C. To solve, let's see what we're missing on this particular triangle. So here's the x, and remember that that hypotenuse is the longest side opposite that 90-degree angle. So we are missing the c, and I can label these, the legs form that 90-degree triangle. I'm going to start with the Pythagorean theorem, and then I'm going to substitute in what I know. I've got that a is 7, b is 17, and c is our unknown value. 7 times 7, remember you can use your squared key. Don't forget about that. To the left of 7, I can type in 7 squared, and that gives me 49. And 17 squared, and that value is 289. So 289, have that in my calculator, plus 49, 338. Okay, now let's see what we do to solve this. So the inverse of squaring is square root, and that's why on the key in yellow, you can use the second button. You can see x squared and square root. Those are inverses of each other. That's why that yellow square root is right with that x squared. So I'm going to square root both sides. Second, x squared, 338. And the value is, I'm going to round to the nearest tenth, 18.4. So again, that would be an approximation. Square root of 338 would be an irrational number. And we just usually round to the nearest tenth, nearest hundredth, whatever the directions would say there. Now, if we look at that value, yeah, that kind of makes sense there, 18.4. You know, if you thought it was 338, you substitute it in there, that just wouldn't make sense. So a lot of times you just have to remember to take that square root. All right, let's check out example 2. Here's the 90-degree angle. So I know this is a leg, this is a leg. Opposite, that would be the hypotenuse. So this time it appears that we are missing the value of the leg, the length of one of the legs that makes up that 90-degree angle. Start with the formula. Substitute in what you know. I have that a is 9. I don't know b. Remember, this could have been interchangeable either way there, and that equals 11 squared. 9 squared, 9 times 9 is 81. And 11 squared, you need to type that in, 121. Now, unlike up above, we added those two legs together and then took the square root. But you can see here the inverse of addition would be subtraction. So I'm going to have to subtract 81. And the value is 40. Now again, if we would say, oh, that leg is 40, that would make sense. Our hypotenuse is 11, so we know that this could not be 40. So we just have to remember that last step is to take the square root. And I'll hit second x squared. Remember that p is right here to the left of 7, and I type in 40. Now I know that's not going to give us, this is not a perfect square. 36 is a perfect square. 49 is a perfect square. So I know that answer is going to be between 6 and 7. And there it is, a 6.3. And so our missing value for the leg would be 6.3. So the big thing you need to determine when you're working these out today is decide if you're missing the hypotenuse, decide if you're missing the leg. Start off with that Pythagorean theorem and then substitute in what you know and just solve from there.